What about the little criticism I saw of by way of question, do you consider the different probabilities of each reaction in the chain? So, like that there could be different. When you look at a chain of events that led up to the creation of an object, doesn't it matter that some parts in the chain are less likely than others?
No.
It doesn't matter.
No. Well, let's go back. So no, not less likely, but react. So no. So let's go back to what we're looking at here. So the assembly index is the minimal path that could have created that object probabilistically. So imagine you have all your atoms in a plasma. You got enough energy. You got enough. There's collisions. What is the quickest way you could zip out that molecule with no reaction constraints?
How do you define quickest there then?
It's just basically walk on a random graph.
Yeah.
So we make an assumption that basically the time scale for forming the bonds. So no, I don't want to say that because it's going to have people obsessing about this point. And your criticism is a really good one. What we're trying to say is like this puts a lower bound on something. Of course, some reactions are less possible than others, but actually, I don't think chemical reactions exist.
Oh boy, what does that mean?
Okay.
Why don't chemical reactions exist?
I'm writing a paper right now that I keep being told I have to finish, and it's called The Origin of Chemical Reactions. And it merely says that reactivity exists as controlled by the laws of quantum mechanics. And reactions, chemists put names on reactions. Like, so you could have like, I don't know, the Wittig reaction, which is by, Wittig. You could have the Suzuki reaction, which is by Suzuki. Now, what are these reactions? So these reactions are constrained by the following. They're constrained by the fact they're on planet Earth, 1G, 298 Kelvin, 1 bar. So these are constraints. They're also constrained by the chemical composition of Earth. Oxygen, availability, all this stuff. And that then allows us to focus in our chemistry. So when a chemist does a reaction, that's a really nice compressed shorthand for constraint application. Glass flask. Pure reagent, temperature, pressure, bomb, control. So, of course, we have bond energies. So the bond energies are kind of intrinsic in a vacuum. If you say that, so the bond energy, you have to have a bond, and so for assembly theory to work, you have to have a bond, which means that bond has to give the molecule certain a half-life. So you're probably going to find later on that some bonds are weaker. And that you are going to miss in mass spectrum. When you look at the assembly of some molecules, you're going to miscount the assembly of the molecule because it falls apart too quickly because the bonds just form. But you can solve that with looking at infrared. So when people think about the probability, they're kind of misunderstanding. Assembly theory says nothing about the chemistry, because chemistry is chemistry and the constraints are put in by biology. There was no chemist on the origin of life, unless you believe in the chemist in the sky, and they were, it's like Santa Claus. They had a lot of work to do. But chemical reactions do not exist in the constraints that allow chemical transformations to occur do exist.
Okay. So it's constraint application. So there's no chemical reactions. It's all constraint application, which enables the emergence of what's a different word for chemical reaction? Transformation.
Yeah, like a function. It's a function. But I love chemical reactions as a shorthand, and so the chemists don't all go mad. I mean, of course, chemical reactions exist on Earth.
It's a shorthand.
It's a shorthand for all these constraints.
For right. So assuming all these constraints that we've been using for so long, we just assume that that's what was the case in natural language conversation.
Exactly. The grammar of chemistry, of course, emerges in reactions, and we can use them reliably. But I do not think the Wittig reaction is accessible on Venus.
Right. And this is useful to remember, to frame it as constraint application is useful for when you zoom out to the bigger picture of the universe and looking at the chemistry of the universe and then starting to apply assembly theory. Yeah. That's interesting. That's really interesting.